Okay, we're now moving on to confidence intervals and hypothesis testing, all right? Some basic concepts. So there's a town, uh, Newton, that has 168 parcels of land, hence the diagram over here. And we don't have time to do a full census. We want to find out what the population is. We want to know mu, the population of the 168 parcels altogether. So since we don't have time to do that, what we can do is take a sample of 21 parcels and take a sample and use that simple random sample. And once we find out that population, the approximate population of one town, then we could multiply that out by 168 to get the estimate the population parameter. That's what we're trying to do. Okay, so we're going to do that part in class, so we need to worry about that. So let's just say that our sample mean was 1,050 people for those 21 towns. Okay, that's just a sample of the number of people there. Well, we'd have our x bar of 1,050, and then when we took our sample standard deviation, let's say it's 82, and we do this by the calculator, then we have to remember to divide that by the square root of 21. Okay, because we have to take into account the sample size when we're doing our computing our sample standard deviation, and then we can go ahead and use this to extrapolate to the entire population. So we'll do that activity in class. So if our sample size is sufficient, we have 21 here, which is getting pretty close. Remember from the central limit theorem, what does that tell us? That tells us that this highlighter's driving me crazy. No, this tells us that x bar is going to have an approximate normal distribution. And we'll have an approximate bell-shaped curve, and we could apply the 68, 95, 99.7 rule. Again, that's other properties of the normal distribution, which we're assuming. We can assume that the mean of our normal distribution is going to be the same as our population mean, right? So that's what we're saying, the mean of our normal sampling mean. Okay, so the mean of our means, or the average of our averages, will get very close to the population average. That's what we're saying. And then we have to divide by the square root of 21, because that takes into account the sample size here. And so let's just say our population standard deviation 32.3, which we don't know. If we don't know the population mean, we're not going to know the population standard deviation. But let's just say, for simplicity's sake, it was 32.3. We would divide by the square root of 21, and we get a sample standard deviation of 7.05, and we'd use that for any future calculations. So remember from the 68, 95, 99.7 rule, and what that tells us is that we have 30%, 34% of our data is going to be one standard deviation to the right of the mean, 34% is going to be one standard deviation to the left of the mean, so 68% of our data is within one standard deviation. Remember that from the past. Now we're applying it here, and likewise here, we're going to have 95% of the population is going to be between two standard deviations right in here. Okay, because 7.05 times 2 gives you 14.1. So you add 14.1 to the population mean, you subtract 14.1. Again, that's unknown at this time, but we're using x bar as our estimator. Again, we're using x bar to estimate mu. Okay, that's what we're saying. So we'll keep going in that regard.